Let's solve the picking numbers problem now on HackerRank. In this problem, we're given an array of integers and we need to find the longest subarray where the absolute difference between any two elements is less than or equal to 1. In this example, we have an array A which is equal to 1, 1, 2, 2, 4, 4, and then 5, 5, 5. There are two subarrays meeting the criterion, 1, 1, 2, 2, and then 4, 4, 5, 5, 5. And the maximum length subarray has 5 elements, so it's actually this one. And so we need to return 5 because that's the number of elements in our maximum length subarray. So the fundamental concept we need to understand here is a subarray essentially consists of elements which are equal to each other or are one digit apart. For example, in this subarray 1, 1, 2, 2, 1 is identical to 1 because, or they are identical, but the reason they make the subarrays because 1 minus 1 is 0, and then 1 minus 2 is 1, and 1 minus 2 is 1. And then similarly for the next subarray, 4 minus 4 is 0, so we can add both those elements to our list. And then 4 minus 5 is 1, 4 minus 5 again is 1, and 4 minus 5 again is 1. So these are our two subarrays. And since this one is longer, we're going to return the length of this subarray. So why is this important? The fact that our subarrays either include numbers that are identical or one digit apart. That's because of the way we're going to solve this. How we're going to solve this is we're going to create a tree map. Why are we using a tree map? That's because we want to sort our keys in a natural order. So in this case, since we're storing a tree map of integers, we're going to store our keys in ascending order. So just to clarify a bit, within our tree map, our key is going to be the values we're on as we're iterating in our array, unique values. And the corresponding value to these keys is the number of times they appear in our array. So for key 1, it appears twice, so its value is 2. For 2, it appears twice again. 4 appears twice, and then 5 appears 3 times. So if we go back to what I mentioned, the fact that our subarrays only include numbers that are identical or one digit apart, we're going to create a counter which initially is the value of our first key. So in this example, our counter is going to be equal to 2 because if we retrieve the value of our first key, which is 1, it appears twice, 2 times. So our current counter is going to be equal to 2. Then, like I said, since the subarray only includes numbers which are equal to each other or one digit apart, and our current counter took account of the values which are equal to each other because, like I said, one appears twice, so we took account of both of them. We're going to check if key plus 1 exists. So if our first key is 1, key plus 1 is 2. If the key 2 exists in our tree map, then we're going to add to our current counter, which was initially 2, the number of times that key plus 1 or 2 appears in our map. And before we do all this, we're actually going to create an integer called max, which is initially equal to 0. And once we find our counter, which includes the numbers which are equal to each other and are one digit apart, we're going to set max equal to this value. This way, we can compare max to other values in our array and digits that are one apart or one digit apart from that value to see if that subarray would be longer than the one which we're currently on. This may seem a bit vague, but I believe we'll understand it through a bit of code. So let's go ahead and begin now. Okay, so first and foremost, we need to create our tree map of integer to integer. We can call it map, and this is equal to new tree map. Then we actually need to store our values in our array and the number of times they appear in our array into our tree map. So let's do that now. For every int number in our array, map.put that number, and map.get or default number, and then 0 plus 1. So real quick, what we're doing here is first we create a tree map of integer to integer. Then we're going to iterate through all the numbers in our array A. And in our map, we're going to put the number that we're on as a key. And then as a value, we're going to put map.getterDefaultNumber, comma 0 plus 1. What this code does, the map.getterDefault, what we're basically doing is as our value, we're either going to retrieve map.getNumber if it already exists in the map, so we don't have duplicates. Otherwise, if number does not exist in our map, then we're going to default to 0 and add 1 because to account for the number which we're on. So basically in our first iteration, map.putNumber is going to put 1, and then map.get or default number, since 1 doesn't exist in our map, it's initially empty, we're going to put as a value 0, and then we're going to add 1 to it to take it into account. So we're going to have a tree map with 1 and its value is 1. Then we're going to go to the next one in our array, and we're going to put it again, but since it already exists, it's going to overwrite the one that already exists, and we're going to put map.getterDefaultNumber, which previously existed in our map, which was map.get at 1 was 1. That's the value of our key 1 initially, and then we're going to add 1 to it again to take into account the next one, and then so on and so forth. So now we have to create int max equals to 0, and this is in order for us to compare subarrays in our array. Then we're going to iterate through every key in our key set. So for every key in our map. So now we have to create our current counter, which is equal to map.getKey. So now our current counter is equal to the number of times our first key for the first iteration appears. Then what we're going to check is if a key which is 1 digit apart from the current key which we're on exists. So if map.contains key plus 1, then we're going to increase, or we're going to add to our current counter the number of times that this key exists in our map. Finally, to keep track of the longest subarray, we're going to use the max variable which we created like this. So if current counter is greater than max, which it initially is, we're going to say max is equal to current counter. That way, once we, if you want, exit a subarray which we're currently on and study a new one, if this subarray has a current counter greater than our old max, then this is going to be our final result, or the length of this subarray. So finally, all we need to do is just return max. Let's submit our code and see if it worked. So there we go, it ran through all test cases successfully. Let's go through an example to make sure the point is made across. We'll study this block of code. So let me initially just write our tree map out. Alright, with our tree map right here, very simple tree map, let's begin. For every int key in map.keyset, so we start with 1, our current counter is going to be equal to the value of the key which we're currently on, so current counter is going to be equal to 2. If map.contains key plus 1, so what's 1 plus 1? That's 2. Does our map contain a key of 2? Yes, it does. Then we're going to add to current counter map.key plus 1, so the value of this key, which is also 2. So now our current counter is equal to 4. And then if current counter is greater than max, which it initially is, since max is equal to 0, max is equal to current counter, so max is equal to 4. And so now we go to our next key, which is 2. 2 is, so current counter is now going to be equal to the number of times 2 appears in our map, which is twice. So current counter equals to 2. Does map.contain key plus 1, which is 2 plus 1, which is 3? It does not, so we're going to skip this. Is current counter greater than max? So is 2 greater than 4? It's not, so we're also going to skip this. And we're going to go to our next key, which is 4. So current counter is equal to the number of times 4 appears in our map, which is twice. So 2. And then does map.contains key plus 1? Yes, it does. 4 plus 1 is 5, and it does appear in our map. So we're going to add to current counter the number of times 5 appears, which is 3. And since our current counter was 2, 2 plus 3, that's 5. Current counter is now equal to 5. And now we're checking, is current counter greater than max? Yes, it is, since 5 is greater than 4. So our new max is equal to 5. And then we go to the final key, which is 5. And if you go through this, key plus 1 doesn't exist, so current counter is going to be equal to 3. And 3 is not greater than max, so our max is officially 5. And then we return 5, which is the correct answer in this example. So I hope you found that video helpful. That was picking numbers on HackerRank, and thanks for watching.